Hello everyone. This is Dr. Rajlakshmi, Professor of EC Department, Aditya Engineering College. Today we are going to discuss the basic introduction to the subject Integrated Circuits and Applications. In this course, we can see that these are the outcomes of our integrated circuits and applications. Here you can see the first course outcome is in the first unit you can be able to introduce the integrated circuit, what is integrated circuit, and how you can be able to construct a basic integrated circuit by using differential amplifier. And later we will discuss the importance of several factors which will affect the basic performance of the integrated circuit. And in the second chapter, we will discuss the op-amp characteristics. And in third chapter, we'll discuss all the applications of op-amp. In the fourth, we'll discuss the A to D and D to A converters in the IC version. And the fifth chapters, we'll discuss about the timers and phase lock loop. Here you can see that the main prerequisite for our course linear applications, linear IC applications is EDC, that is electronic devices and circuits, as well as electronic circuit analysis. The textbooks preferred for these linear integrated circuits are linear ICs by D. Roy Chaudhary and op-amps and linear ICs by Ramakant A. Gaikwad. So coming to this course contents, the first chapter, as we already discussed, that we are going to discuss we are going to introduce the concept of integrated circuits and the internal construction. We'll discuss in the chapter 1. In the chapter 2, we'll completely discuss about the characteristics of op-amps. So like all ideal practical characteristics. Similarly, DC as well as AC characteristics of op-amp will be discussed in. We will discuss it in the chapter 2. And in the unit 3, we will discuss all the linear as well as non-linear applications of op-amp. Next, in the unit 4, we will discuss the A to D and D to A conversions as well as the active filters constructed by using these ICs, linear ICs. And in the unit 5, we are going to discuss the concept of timers as well as phase lock loops. Now, before going to the course contents, first of all, we should know what is an integrated circuit. Generally, an integrated circuit is a one where the discrete components may be active or passive. So, active as well as passive discrete components will be fabricated on the single silicon chip. So that fabrication is done that's the process of preparing the IC, so which is irreparably joined together on a single silicon chip. So active components include like diodes, transistors, MOSFETs, field effect transistor, or a unipolar junction transistor. So all these are the active elements, and passive elements include the resistor, capacitor, and inductor. These elements will be fabricated on a single silicon area. Or sometimes if it is a hybrid IC, instead of single, these chips will be again metallized. And in the year 1958, you can see the first prototype IC, which has been introduced by Jack Kilby at Texas Instruments, and this has been introduced in 1958. Here you can see the size of the IC at the time. Now, as the decades has been going on, and again in 1959, the next year itself, Robert Noyce he invented the first monolithic integrated circuit. This monolithic, the name implies that mono and lithic. That's this IC has been constructed or fabricated on a single stone or single silicon chip. That's why it is called as monolithic integrated circuit. And this has been the manufacturer for this is Fairchild Semiconductor. And next, here you can see the amplifier which has been constructed with discrete components. So if this is constructed upon a breadboard, it takes a lot of space to like occupancy is very more. And if it is fabricated, then you can see it's how it is like how the size has been minimized. So this is the amplifier in IC form. So it has 12 pins, and you can see a knob here. From that you have to count, like you can see the pins starting from 1 to 6, and seventh pin exactly opposite to the 6. This seventh pin is extended to 12. Here you can see the various pins for the amplifier, and here the main advantage of this IC is miniaturization. So here you can see the amplifier using discrete components, and the same is constructed in the IC form with less space. So these are all the advantages of an IC. So those include the miniaturization, as what we have seen now. The size has been drastically reduced, and it's highly economical because it's mass produced, and similarly the weight of this IC is very less, and with low power supply voltages like in the range of plus or minus 15 volts, because an IC need both positive as well as a negative power supplies. The maximum of ICs need positive as well as negative power supplies. Similarly, the power consumption is also very low, and it's highly reliable until and unless we damage. So, and it like it has high compatibility to match with the other elements. Similarly, the operating speed of this IC is also very high. And a linear IC is a one where the output is directly proportional to the input and capable of delivering more power to the load. So linear IC is preferred, but here you need to stabilize the operating characteristics because of its external circuitry. And here you can see some of the best linear ICs. And this 741 IC is a general purpose operational amplifier. And here you can see this is 8-pin dual inline package. So because the pins are in dual lines, it is called as dual inline package, DIP, dual inline package. So it has 8 pins starting from 4 on one side and 4 on other side. These are parallel to the rectangular housing. And in the second figure you can see this IC741 has been manufactured by Texas Instruments. Here SN represents that it has been manufactured by Texas Instruments. That we will discuss in the ordering of an IC information. And here you can see first pin is, it's not connected anything there, and the second and third pins are, second pin is inverting input, third pin is non-inverting input, and our fourth and seventh pins are positive and negative power supplies. Okay, and sixth pin is the output. Like that, these 8 pins, out of 8 pins, only one pin is not yet used, and the 7 pins are active here. So that's why it is called as 741. So 7 active pins and 4 inputs and 1 output. So that's why it is a dual inline package, and this is also called as mini dual inline package, mini DIP. And another example for the linear IC is IC555 timer. It acts as a timer. So here control pin is 5th pin, and here 3 5K resistors are used in the chip. So it's defined as IC555. It acts as a timer. Similarly, A to D converter, the best example for this IC is 0808 IC. And for digital to analog converter, again same IC is used. Phase locked loop, IC565.